Hi friends, welcome to Tutor Lokesh channel. ఇవాళ మనము Cbse 10th class కి సంబంధించిన ఎంటైర్ మ్యాథమెటిక్స్ లో ఇంపార్టెంట్ క్వశ్చన్స్ మనము డిస్కస్ చేయబోతున్నాం. అదేవిధంగా బోర్డ్ ఎగ్జామ్ కి ఎలా ప్రిపేర్ అవ్వాలి, బోర్డ్ ఎగ్జామ్ కి ఏ క్వశ్చన్స్ మనకి ఎక్కువ వచ్చే అవకాశం ఉన్నది కూడా మనము డిస్కస్ చేయబోతున్నాం. రైట్, అయితే చాప్టర్ వైజ్ మనం ఒకసారి డిస్కస్ చేద్దాం. సో ముందుగా ఫస్ట్ చాప్టర్ చూసుకుంటే మనము రైట్, సో లెట్ మీ టేక్ ద ఫస్ట్ చాప్టర్. ఇంకా చూడండి, ఎక్సైజ్ 1.1 చూసుకున్నట్టయితే యూక్లిడ్ డివిజన్ ఉంది. యూక్లిడ్ డివిజన్ అల్గారిథం 135 × 25 హెచ్సిఎఫ్ కనుక్కోవాలి. రైట్, ఇంకోటి వచ్చేసి షో దట్ ఎనీ పాజిటివ్ డిజిట్ ఆఫ్ ద ఫార్మ్ 6³ + 1 6³ + 3 ఓకే, an army contingent of ఓకే, యూక్లిడ్ డివిజన్ 3m ఓకే, 9m ప్లస్ అంటే ఇదంతా కూడా యూక్లిడ్ డివిజన్ చాప్టర్ పైన ఉందన్నమాట. యూక్లిడ్ డివిజన్ టాపిక్ పైన. సో ఖచ్చితంగా ఈ 5 క్వశ్చన్ల నుంచి ఇదొకటి, ఈ 4 నుంచి ఇదొకటి రావడానికి ఛాన్స్ ఉందన్నమాట. ఓకే ఓకే, యూ విల్ గెట్ అట్లీస్ట్ 2 questions from this exercise. One question for 4 marks and 1 question either for 1 mark or for 2 marks. So let me explain you the questions in this exercise. So let me start with the 135 × 25. So using Euclid division. Finding HCF for 135 and 225. Finding HCF for 135 and 225. So now what we have to do? ఒకసారి యూక్లిడ్ డివిజన్ గురించి ఎక్స్ప్లెయిన్ చేస్తాను చూడండి. నా ఫస్ట్ టాపిక్ ఏంటంటే నేను మీకు యూక్లిడ్ డివిజన్ గురించి ఎక్స్ప్లెయిన్ చేయడం జరుగుతుంది. సో వాట్ వీ హ్యావ్ టు డూ? ఫస్ట్ వీ హ్యావ్ టు డూ నార్మల్ డివిజన్. వాట్ ఈస్ నార్మల్ డివిజన్? We have to take small number as divisor and we have to take big number as dividend, and we have to start division. Okay, again I'm telling, we have to take small number as divisor, small number as divisor, and big number as dividend, big number as dividend. We have to take small number as divisor and big number as dividend. Now we have to start doing division. 135 and 225. Since we can guess or easily we can understand that 135 2s are is 270. See, 100 2s are 200, 35 to 70. So 135 2s are is definitely 270. So 135 1s are, I'll take 135 and subtraction, after subtraction we will get 90. Since 5 minus 5 is 0 and 22 minus 13 is 9. So it is the process as we already know. ఇక్కడ వరకు మనకి ఆల్రెడీ చేసుకోవడం తెలుసు అనమాట. అయితే what we have to do specially for finding HCF is after getting remainder again we have to take it as divisor, and we have to take this number we have to take the earlier divisor as now dividend 90 135. So 90 135. So 91s are 90. We cannot take 92s as, since 92s will be 180 which is greater than 135. So I am taking 91s are 90 and the remainder is 45, and we have to take 90 as a dividend. So 45 1s are 45 2s are 90 and the remainder is 0, and the remainder is 0. 45 2s are 90. So now we are getting 0 as remainder for this divisor 45. So therefore it is the HCF. Therefore it is our answer, and it is the HCF. Again I am telling, we have to do normal division, and after getting remainder we have to take it as divisor, and what we have to take as dividend? The earlier divisor we have to take it as dividend, and we have to start again doing division. After getting another remainder, what we have to do? We have to take this 90 as dividend, and we have to start doing division until we get the remainder as 0. What we have to do after getting remainder 0? After getting remainder 0, the corresponding divisor is the answer, and it will be the HCF. After getting remainder 0, the concerned HCF, the corresponding HCF where we are getting the corresponding divisor where we are getting remainder 0 is the answer, and it will be the HCF, and it will be the HCF. Now how to write this division in Euclid division lemma method means, so the answer is correct. Now we are getting the answer is correct, and how to represent in equation format, that we have to understand, and that we have to learn and apply. See, from childhood we already learned that we have already learned that dividend is equal to divisor into quotient plus remainder. One second. Yeah, dividend is equal to divisor into quotient plus remainder. And for those who don't know what is dividend, what is divisor, and what is quotient remainder, let me explain you this example. So I am taking the same division example. 135 ones are 135, remainder is 90. So here the small number with which we are dividing is known as divisor, and the big number is dividend. This number is divisor, and this is quotient, and this is remainder. It is divisor, it is dividend, it is quotient, remainder. This divisor, the middle number with which we have to divide, is known as dividend, and the answer we are getting, it is known as quotient, and the final after subtraction what we are getting a number is known as remainder. So there is a division rule. Which we have studied in the earlier class of maths. In 8th class, 9th class, 7th class. So that rule is dividend is equal to divisor into quotient plus remainder. Now how we have to write? We have to take each and every division like this. So the first division is like this. This is first division, and we have to write in this format. Dividend, what is dividend? 225. So 225 is equal to 135 into 1 plus remainder 90 and we have to take second division. What is second division? Up till here second division. So 135 is equal to 90 into 1 plus 45, and we have to take third division. Okay, so 90 is equal to 45 into 2 plus 0 and after that where we are getting remainder 0, the corresponding divisor is known as HCF. The corresponding divisor is known as HCF. Okay, so like this we have to do Euclid division lemma, and we have to find HCF. Now we will discuss one more topic. Yeah, similarly we can do this, and similarly we can do this. Okay, now one more type of question is that we have to use Euclid division lemma, and we have to prove the statements like show that any positive odd integer is of the form 6 cube plus 1, 6 cube plus 3, and 6 cube plus 5. And one more problem is that you have to use Euclid division lemma to show that square of any positive integer is either of the form 3m plus 1 for some integer, and again use Euclid division lemma to show that cube of any positive integer is of the form 9m plus 1 and 9m plus 8. What we have to do and how we have to do, we will discuss now. Let me explain you once again the question number 2, because I am going to do the question number 2 now. Show that any positive integer, odd integer, is of the form 6 cube plus 1, 6 cube plus 3, 6 cube plus 5. So let me write there once again. any positive odd integer 6 cube plus 1, right? 6 cube plus 1, 6 cube plus 6 plus 5, 6 cube plus 1, 6 cube plus 3, 6 cube plus 5. Okay, so these type of questions are pretty easy, and these are most repeated for board exams. And how we have to do is, now we have to focus. Yeah, let me use the black ink. I am telling you again the division rule. First write the division rule. Division rule is dividend is equal to divisor into quotient plus remainder. Dividend is equal to divisor into quotient plus remainder. It is a basic division rule, we all know. Now I'm taking let A be the dividend, and let B be the divisor, and Q be the quotient, and R be the remainder, so that I can write the division rule as A is equal to B into Q plus R, which is the most vital and most important point for this type of problems. I'm telling you, from division rule we can write as dividend is equal to divisor into quotient plus remainder, and after assuming dividend as A and divisor as B, we can write the same equation. We can write the same equation as A is equal to B into Q plus R. A is equal to B into Q plus R. Now what we have to prove? We have to prove that any positive integer, any positive odd integer is of the form 6q plus 1, 6q plus 3, and 6q plus 5. My only suggestion and my only advice for you for these type of problems is, the only thing is what we have to remember is, just see this number, 6, and that is the same number we have to take as B value. That is the only thing we have to remember in this type of problems. See, in the question itself they will give 6q plus 1 or 3m plus 1 or 9m plus 1. That number itself we have to take as B value. Okay, so now after let us take B is equal to 6. Therefore I can write A is equal to 6q plus R. A is equal to 6q plus R. I can take A is equal to 6q plus R. Now the equation is A is equal to 6q plus R. Now for R is equal to different values, we will get different numbers. Now since we have to take any positive odd integers, we have to take R value as 1, 3, 5, like that. So for R is equal to 1, A value will be A is equal to 6q plus 1, 6q plus 1. Now since we have to take only odd numbers, let me take one more number, odd number, as 3. So now substitute R value here, Now the equation will be A is equal to 6q plus 3. 6q plus 3 వస్తుంది. And similar way for R is equal to 5, we will get A is equal to 6q plus 5. So therefore our answers will be A is equal to 6q plus 1, A is equal to 6q plus 3, and A is equal to 6q plus 5. In this manner we have done the question actually, and that's what the answer is, and that's what we have to prove, There ends a matter, and this is how the question looks like. Let me write you the question. Yeah, see, the question is asked like this: show that any positive odd integer is of the form 6q plus 1, 6q plus 3, and 6q plus 5. And I already told that For all these type of questions which will be asked in this manner, like 6 cube plus 1, 6 cube plus 3, or 9m plus 1, 3m plus 1, the first and foremost thing we have to remember is the division rule. And what division rule says? Division rule says dividend is equal to divisor into quotient plus remainder. What division rule says? Division rule is, dividend is equal to divisor into quotient plus remainder. For those who don't know what is dividend, divisor, quotient and remainder, in this video only at the starting I have explained what is division and what is divisor and dividend. Okay, so leave it. Now what you have to remember, dividend is equal to divisor into quotient plus remainder. Let us take dividend as A and divisor as B, so that we will get the equation somewhat simpler form. It will look like A is equal to B cube plus R, and the equation will be A is equal to 6 cube plus 6. And what we have to take B value, that is the thing, most important thing. What we have to take B value depends on the question. If the question is being asked like 6 cube, we have to take B value 6. If the question is being asked like 3m, we have to take B value as 3. And if the question is asked like 9m, for 9 we can take B value as 3 or 9. No matter what we have to take, no matter what can we take, it doesn't have the solution. Now till here it is easy. There is nothing wrong. There is nothing harder up to this level. Now what we have to prove is we have to read the question once again for the required statement. He is asking that show that any positive odd integer is of the form 6 cube plus 1, 6 cube plus 3 and 6 cube plus 5. That means we have to take only positive odd integers. We have to take only positive odd integers. So I am asking you, what will be the odd integers? What are the odd integers? 1, 3, 5, like that. So for different R values, since 6 value is fixed and quotient is fixed and dividend is fixed, we can change only the remainder. So that will be R is equal to 1. If you put R is equal to 1, the answer will be 6 cube plus 1. If you put R is equal to 3, the answer will be 6 cube plus 3. And if we put R is equal to 5, we will get 6 cube plus 5. And that is what we have to prove in this question. And this question will be asked for 4 marks in the board exam. 4 marks in the board exam. Now I will explain the same type of questions in the same manner in a very easier method. Okay, so stay tuned. We will solve one more question here. Let me take, see here, the fourth question will solve. Use Euclid division lemma to show that the square, just see here, I am highlighting the point, show that the square of any positive integer is either of the form 3m plus 1, 3m plus 1 for some integer m. Square of any positive integer, right? Yeah. Is it clear? And this is what the question is being asked there. Show that square of any positive integer is either of the form 3m plus 1. Now I am telling you again and again, for any question which is asked on Euclid division lemma topic, the first and foremost thing we have to remember and we have to write is the division rule. What does the division rule says? The division rule says like dividend is equal to divisor into quotient. I'm just writing the shortcut of quotient. Actually the quotient spelling is like this, so every time I am not able to write the right spelling. Divisor into quotient plus remainder, divisor into quotient plus remainder. Dividend is equal to divisor into quotient plus remainder. This equation I will write in a very simpler manner as A is equal to B into Q plus r. A is equal to b into q plus r, and this is what the important thing for these type of problems. Now, the first and foremost thing what I told in the earlier problem is taking the b value. Taking the b value. What value we can take b value? It depends on the question. See, the question is being asked in such a way that we have to get the value as 3m or 3m plus 1. The question is being asked in such a way that we have to get b value as 3m or 3m plus 1. So what we have to take? We have to take b value as only 3, and after taking b value as 3, the equation can be rewritten as a is equal to 3q plus r. 3q plus r. I will just write the b value how we have to take and how we have to write, so that the evaluator who is correcting your paper can understand. So consider b is equal to 3. Consider b is equal to 3. So a is equal to 3q plus r. A is equal to 3q plus r. I can write this equation as equation 1. So till now a level of one step has been completed. Now what we have to do? We have to read the question again for what we have to do. The question is being asked in such a way that we have to consider the square of any positive integer. The square of any positive integer. We have to take square of any positive integer, not only odd integer, any positive integer, right? So let me take r value as 0. Now for r is equal to 0, a is equal to 3q plus 0. Therefore a is equal to 3q. A is equal to 3q. Now what we have to do? We have to square the positive integer. That means after squaring, a square is equal to 3q whole square. That will be 9q square. A square is equal to 9q square. A square is equal to 9q square. Okay. Now what we have to prove? We have to prove square of any integer is of the form of 3m or 3m plus 1. So I can take 9q square, I can take 3 common. So 3 into 3q square I can write now. 9q square I can write as 3 into 3q square. So it will be of the form 3 into m. A square is equal to 3 into m. A square is equal to 3 into m. So half of the answer is completed. Now I will take r value as 1. For r is equal to a is equal to 3q plus 1. Now squaring. After squaring, what we will get? 3q plus 1 whole square. Since it is in the form of a plus b whole square, we have to apply that formula. That means 3q whole square plus 2 into 3q into 1 plus 1. That means 9q square plus 6q plus 1. Again, from these two numbers we can take 3 common. That means 3 into 3q square plus 2q. Okay, have you understand? From 9 and 6 we are taking 3 common. Taking common means it is indirectly dividing. So by taking 3 as common, so we'll get out of, here it is 9. If you take common as 3, it will be 3 into 3. So I am writing 3. And from 6 we have to, if you take 3 as common, it will be 2. Since 3 3 is 9 and 3 2 is 6. Okay, like that. So I can assume this entire number as some m. And the answer will be 3m plus 1. 3m plus 1. Right? So again, that is what we have to prove. And it is what it is being asked. That is what it is being asked in the question. 3m and 3m plus 1. See here. I am explaining you again. After seeing these type of Euclid division lemma questions, the first and foremost thing that you have to remember is to write the division rule as dividend is equal to divisor into quotient plus remainder, and we have to write in simplest form, like it is in the form of a is equal to bq plus r. And the important thing in this step is taking b value. The b value depends on the question. So if the question is being asked to show that as 3m, you have to take b value as 3. If it is asked as 6m, you have to take b value as 6. And after getting b value, we will get the equation like this. And we have to take and we have to put r values in different ways. If it is positive numbers, we can take r is equal to 1, 2, 3. And if it is squares, we have to do square like that. Okay, understood? Easy, man. No, what you call these these questions are one of the simplest forms of understanding the Euclid lemma. So it is one of the base for mathematical induction which is being asked in inter first year. You don't need to panic, just read it once again or just practice it once again. You can understand clearly. There is no such thing as the tough in this type of problems. And I am doing one more problem to show that the cube of any number is 9m, 9m plus 1, 9m plus 8. Okay, see this clearly. We have to prove cube of any number is of the form 9m, 9m plus 1, 9m plus 8. Okay, yeah, I am doing fifth question. Cube of any number is of the form 9m, 9m plus 1, 9m plus 8. So again I am telling, when you saw these type of questions like the questions on Euclid division lemma, you have to get the idea of applying division rule. So let me write the division rule first. So what does the division rule says? Division rule says dividend is equal to divisor into quotient. Divisor into quotient plus remainder. Dividend is equal to divisor into quotient plus remainder. To be more precise, I am taking this value as A and this value as P, Q and R. So the equation can be rewritten as A is equal to BQ plus R. And I already told it. So for taking B value, we have to see the question. The question is asked to prove in and we have to prove that that value should be in the 9m plus 1, 9m plus 8. If it is asked like 3, we can take B value as 3. If it is asked like 6, we can take B value as 6. But if it is asked as 9, we can take either 9 or 3. Okay. For this thing, we have that chance. So I am taking B value as 3. So for B is equal to 3, the equation can be rewritten as A is equal to 3Q plus R. A is equal to 3Q plus R. This is equation 1. Till here, step 1 is completed. Now, observe carefully. Now read the question, what you have to do. Cube of any number. I'm sorry, this equation is okay. Yeah. Now, consider for R is equal to 0. The equation will be put R value 0 here. So then A is equal to 3Q. A is equal to 3Q plus 0 means 3Q. Now what we have to do? We have to cube. For that thing, we have to see the question. Either we have to do square, or we have to do cube, or we have to take odd integer, or we have to take positive integer. mean even integer, that depends on the question. So for that thing, read the question carefully after completing step 1. After completing step 1, read the question carefully again. So that you can understand what we have to do. What we have to do as square jala, the cube jala. So it depends on that. So here we have to do cube. Now after cubing, 3q whole cube. That means 27q cube. What we have to prove? We have to prove in the form of 9m. So I will take 9 as common. So 9 into 3q cube. It will be 9m. We got the answer. We got the answer. Now for consider for r is equal to 1. Now for the same equation, put r is equal to 1, and the equation would be a is equal to 3q plus 1. For the same equation, put r is equal to 1, and the equation will be a is equal to 3q plus 1. Again we have to cube. 3q plus 1 whole cube. See, since we know that a plus b whole cube formula, I am writing here a plus b whole cube. We can write as we can write a plus b whole cube in two methods, like a cube plus 3a square b plus 3ab square plus b cube, or we can write it as a cube plus b cube plus 3ab into a plus b. A cube plus b cube plus 3ab into a plus b. So in the same way I can use this thing, since we can take common easily. So it will be 3q whole cube plus 1 cube plus 3 into 3q into 1 into 3q plus 1. So it will be 27q cube plus 1 plus 9q into 3q plus 1. From here and here we can take 9 as common. So let me adjust the screen. So let me write those two terms side by side. After that we can take 9 common. 27q cube plus 9q into 3q plus 1 plus 1. Even no, we have written here. So from these two terms I can take 9 common. So here it will be 3q cube, because after taking 9 common it will be 3. So 9 3 is 27. We get here 9 is common. After taking 9 common, there will be nothing. There will be 1. 1q into 3q plus 1, close the bracket, and 1. Now we can take entire this value as some m. So the answer will be 9m plus 1. The answer will be 9m plus 1. And now we have to prove not only 2 terms, we have to prove for 3 terms. That is what the question is being asked here. So 9m plus 1 and 9m plus 8, and we have to take r value as 2. For r is equal to 2, the same equation, a is equal to 3q plus 2. Cube cheste 3q plus 2 whole cube. So that would be, I am using the same formula. So a cube plus b cube plus 3ab into a plus b. So that what we'll get, we will get 27q cube plus 8 plus 3 3 is 9, 9 2 is 18, 18q into 3q plus 2. So I am writing this term and this term side by side, so that it will be easier to take common. 27q cube plus 18q into 3q plus 2 plus 8. So from these two terms I will take 9 common. So after taking 9 common, it will be 3q cube plus 2q into 3q plus 2 plus 8. So the answer would be 9m. I can assume this entire term as some m. So it will be 9m plus 8, and that is what we have to prove. 9m plus 1, 9m plus 8, and already we have done for 9m. Sorry. Yeah, this would be our answer. Let me zoom out the screen so that you can see the entire answer at a time. Yeah. Yeah, here it is. The only thing what we have to change in your exam paper is you have to write, you don't have to write side by side, we have to write down by down. That is the only thing you have to change in the exam paper. Okay, understood? I'm telling you again, if the questions are asked on Euclid division or it is theorem or finding HCF, we have to write the division rule first, and we have to write in the simplest form, that will be A is equal to BQ plus R, and the B value depends upon question. The B value depends upon question. If it is asked to prove it is in the form of 3m, we can take B value as 3. If it is asked to prove in 6m, we can take B value as 6. But if it is asked to prove in 9m, we can take B value as 3, or we can take B value as 9. Since it will be tougher when we cube the 9 value, it will be tougher. So for that thing only we can take B value as 3, so that even after cubing we'll get some small numbers, right? So what we have to do after that, we have to take different R values, and what we have to do, we have to do squaring or cubing. It depends on question. If it is asked to square, we have to square. If it is asked to cube, we have to cube, and we have to write in this format. Even though you get the answer, and if you're not getting the answer, you have to write in the format, so that he may assume he got the answer, and student got the answer, will get marks. Okay, I'm telling you the secret. Even if you are not getting the answer, if you struggle for the question and you are not getting the answer, the thing is you have to write what it is asked to prove. Okay, so then you'll get marks. Okay, so this question will be asked for 4 marks in the board exam. Okay, now we will do one more problem. Now see here, I'm doing the third problem. The third problem is just it seems like studying a big problem, but it doesn't have any some rocket science technology. There is nothing in this problem. We have to find HCF. Let me explain you more clearly when we have to take LCM, when we have to take HCF. If the question is asked like, find the minimum value, find the least value, find the at least value, then we have to take LCM. If the question is being asked like maximum, see here, maximum, what is the maximum, what is the greatest, okay, what is the largest, then we have to take HCF. Understand the question, read the question, and apply your knowledge on the question. I'm telling you once again, if the question is asked like word questions like 2 members taking some time, 2 members taking time to a lap a ring, or 2 bells ringing at the same time, for those questions what we have to do, we have to do LCM and HCF, but it depends on the question. If it is asked like maximum, greatest, more, we have to find HCF. If it is asked like minimum, least, we have to find LCM. Now in this question it is asked to find maximum. Simply we have to find 616, 32, HCF for 32 and 616, HCF for 32 and 616. I'm writing here for one second. for word problems, for word problems, if you find the terms like least, minimum, or at least, we have to find LCM. If you find words like maximum, greatest, more, we have to find HCF. We have to find HCF. So that is what we have to find. Right. Now the question is asked a group of an army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? 616 and 32. We have to find maximum because we have to find HCF because in the question it is asked like that, what is the maximum number of columns in which they can march. That means we have to find HCF because maximum term or greatest term or more term, then we have to find HCF. Right. So what we have to do here, we have to find HCF. Again, I told you we can find HCF either by using a prime factorization method or by using Euclid division lemma. Since we are asked to find only HCF, we can use Euclid division lemma. And sometimes it will be asked like for the same question, we have to find LCM and HCF. Then we can do prime factorization and using powers, least powers of common terms and highest powers of all terms, we can find at a time both LCM and HCF. Since it is asked here to find HCF only, we can use Euclid division lemma. So what we have to, what Euclid division lemma says, take the small number as divisor and big number as division. We have to do division. So 32 2s are 64, which is greater than 61. I'll take 32 1s are 32, and the remainder will be 29. Since 11 minus 2 9, here it will be 5 minus 3 2. So 29. I am getting down this number. So 32 296. 32 8s are, so 8 2 is 16, 8 3 is 24, 24 plus 1 25. Let me take 32 into 9, 9 2 is 18, 9 3 is 27, 27 plus 1 28. So 32 8s are, it will be 288, and the remainder will be subtraction. After subtraction we'll get 8. 16 minus 8 8 minus 8 0 8. Now what we have to do, we have to take this 8 as divisor and we have to take this 32 as dividend, and we have to do division again. 8 4 is 32 and the remainder will be 0. So where we are getting remainder 0, that thing we can make, so that the answer is HCF. The answer is HCF. The answer, the divisor where the remainder will be 0, the corresponding divisor is our HCF. Here HCF is 8. Here HCF is 8. So let me check the answer once. Yeah. Okay. So this is what exercise 1.1 looks like. Let me So now we will do some more problems on this chapter. We have to do the scientist of this chapter, Carl Friedrich Gauss. Gauss is very famous scientist and also a mathematician. I'm not telling he's only a scientist, he's also a mathematician. See, the physics, science and maths are interrelated. So moreover, physics and maths are more interrelated when compared to other branches of science. Maths is more related to physics. Yeah. Now this question will be asked for 2 marks, and one of this question, either 6 or 7 or 6th question, will be asked for 2 marks, and this question is asked for 2 marks. See, there is nothing like it can't be asked. The entire problems in this exercise are quite simple, and any of these questions will be asked. That's why I'm not telling you, I'm not able to tell you which question to learn perfectly, but I'm telling you all the questions, because all of the questions are simple. So there is nothing such like what you call it gunshot questions or damn shot questions. See, the problems are very simple, and all these problems are asked for 2 marks. We can't predict problems exactly for 2 marks. It depends. From last year, it is. I mean, the question paper is divided like that. For the questions asked for standard set of paper and the questions asked for basic set of paper are quite different. And for basic paper, you don't need to bother anyone. You don't need to bother about that thing. The questions are quite easier, very easier. And in this exercise, you will just get how to do LCM and HCF of this problem or this problem. That's it. I mean, for a basic set, you will be asked only for third problem. For standard questions, you have to learn. For standard set of paper, you have to learn entire exercise. For those who are only preparing for basic level, in this exercise, only third problem is enough. Only third problem is enough. But for those who are preparing for standard set of paper, Cbse board exam, you have to learn entire exercise. Again, I am telling third problem is enough for basic set of question paper, right? But let me explain you the entire exercise. Now, let us take. I'll take some 3 problems out of these 5 problems. Let me take 156, 5005, and 7429. Let me take these 3 problems and explain you. We have to express it as prime factors. Okay. Prime factors. So out of those 5 problems in exercise 1.2 first question, I am taking 3 problems. So let me write the questions of those 3 problems first. See, observe the solution carefully. I will explain you this method in a very simplest method, and what I mean what you have studied in your primary classes, higher secondary classes in 6th, 7th, 8th. The thing is, we have to find LCM. See here, take 156. Start with 2. Remember, to find LCM, we have to start with 2 and then 3 and then 5 and then 7, like that. Okay, even the number can be directly divisible by 7 or 5 or 3. First start with 2. If it is not divisible by 2, then move for 3. If it is not divisible by 3, then move for 5. Okay, and we have to divide only with the prime numbers. We should not take 4, we should not take 6, we should not take 8, such numbers we should not take. We have to take only prime numbers for this division. Let me start with 2. 2 7s are 14, 1 remainder 16, 2 8s are 16. I think you all know how to do LCM. 2 7s are 14, 1 will be the remainder, and 1 6 will be 16, 2 8s are 16. Again, 17 is even number, it will be divisible by 2, so 2 39s are. And 39 is an odd number, so it cannot be divisible by 2. So I am taking 3. So 3 table in 33 is 39. So you'll get 13. So 13 is a prime number. So you can't divide 13 by another number. So stop. You can stop here. So the answer would be 2 into 2 into 3 into 13. We can write it as 2 power 2 into 3 power 1 into 13 power 1. Okay. So you have to know the arrangement, and you have to know the pattern of this number, because that is important. You will get LCM and HCF using just methods only. Now take 5005. See, since it is odd number, because the number is ending with 5, 5 is odd number, the entire number will be odd number. So odd numbers are not divisible by 2. So I can take 3. But before taking 3, we have to check whether the number is divisible by 3 or not. See, what is the divisible root of 3? We have to add digits. 5 plus 5, 10. Is 10 divisible by 3? No. Is 10 divisible by 3? No. That means the number is not also not divisible by 3. Then we have to take 5. Since the number is ending with 5, it is definitely divisible by 5. So 5 ones are, 5 zeros are, 5 ones are again. The number is ending with 1, so it is not an odd, it is not an even number, it is not divisible by 2. And 1 plus 1 is 2, 2 is not also divisible by 3, so it is not divisible by 3. And there is no 5, if a number is divisible by 5, it should be ending with either 0 or 5, so it is not also divisible by 5. And what we have to take, we have to check for 7 or 11. But I am telling you the secret for checking with 11. If the numbers repeat in the same gap, like 1 0 0 1, 1 0 1 1 0 1 1 0 1, or 7 0 0 7, or 7 0 7, like that. If the numbers repeat with the same gap or some in the same manner, so those numbers are more likely to be divisible by 11. So for that reason I am taking 11. 11 nines are 99. 1 will be the remainder. 1 1 means 11 ones are 11. Again 91. 91. Let me check 14. Okay. I think it will be divisible by 7, right? So I am taking 7. No problem. 7 1s are 7. 3 0 30. 7 4 is 28. 2 1. 7 3 is 21. Now is it divisible by 2? No, it is an odd number. 3? No. 8? No. 5? No. 7? Yeah. 7 2? No. 7 also no. Now we have to take 11. Now we have to take 11. 11 ones are 11. 3 3 33. 11 3 is 33 and 13. So 5 into 7 into 11 into 13. Similarly 7 4 2 9. Since it is an odd number, it is not divisible by 2, and for a divisible rule by 3, we have to check by adding 7 plus 4 11, 11 plus 2 13, 13 plus 9 22, 22 is not divisible by 3, so it is not divisible by 3. And I am telling you straight away, it is divisible by 17. So in the meanwhile I have checked with 11 7 13 all these things, but it is not divisible by either of those numbers, 11 7 13. So I am telling you the number which divides this number is 17. So 17 4 is 68, and 6 will be remainder 62, and 17 3 is 51, and 11 will be remainder, that will be the number will be 119, the number will be 119 119, and 17 7s are 119. And now we have to check with 19. 19 to 38, 5 will be remainder 57, and 19 3 is 57. So 23 is a prime number, so it will be divisible by only 23. So the answer would be 17 into 19 into 23. So writing the answer as this is nothing but expressing the solution as prime factors. Okay. Now see here, in the second question it is asked like find LCM and HCF of two numbers and verify that LCM and HCF is nothing but product of number. This is very important and useful for your competitive examinations in higher standards. LCM and the product of LCM and HCF is equal to product of two numbers. The product of LCM and HCF will be equal to product of two numbers. That means, let me explain you with an example: 26 and 91 and 510 and 92. verify LCM into HCF is equal to product of those two numbers, product of so 26 and 91. Let me do for 26 and 91. See, I've told you earlier itself, if we are asked to find LCM and HCF, if we are asked to find LCM and HCF at a time, then we can use prime factorize method. Okay, if we are asked to find HCF only, then we can use Euclid division. If we are asked to find LCM and HCF at a time, then we can use this prime factors method. Okay, so first let me write prime factors for 26. So just take 26. Take 26. 2 13s are 13 ones are. So it will be 2 into 13, and take 91. It will be 7 into 13. So 7 into 13. So now I will write the definition of LCM and definition of HCF. For prime factors, LCM will be highest powers of all terms. LCM will be highest powers of all terms. Just remember this very important formula. Highest powers of all terms. HCF would be least power of common terms. So like that, highest powers of all terms. All terms means what are all visible to you. The terms which are there, we have to write every term. 2, 13, 7, 13. But don't repeat terms. Okay. So 2 into 13 into 7. And we have to write highest powers. What is 2 power 1? 7 power 1, 13 power 1. So the answer would be 182. Since 13 7th 91, 91 2 is 182. Now we have to find the least powers of common terms, HCF. HCF means least powers of common terms. Now first find common terms. What will be the common terms? 13, 13. 13 is only the common term for these two numbers. So 13, and we have to write least power of that 13. Here the power of 13 is 1. Here also the power of 13 is 1. So the least power will be automatically 1. So the answer is 13. This 13. So in this way we will find LCM and HCF, and we have to verify the product of LCM and HCF with the product of the two numbers, those two numbers. So let me verify here. LCM into HCF will be 182 into 13. So the answer would be 13 is 26. 13 8 104 plus 2 106. And 13 1 is 13, 13 plus 10, 23. 2, 3, 6, 6. And product of two numbers. 26 into 91. Two numbers means 26 into 91. So let me do the multiplication. 1 6 are 6, 1 2 are 2, primary school multiplication. 9 6 are 54, 9 2 is 18, 18 plus 5 23. So the answer would be 6 6 2 3. So the answer is verified here, 2366. Here also the answer is verified, 2366. Okay. Now we will do one more problem so that you will get expertise with this method. Let me take a big problem so that you will be getting challenges in the exam, so that you will face easily those challenges. So let me do the prime factorization, and for prime factorization the only thing I will do is just to find LCM. Just to find LCM. 5 10. 2 2s are 4 and 1 is remainder. 11. 2 5s are 10. Again 1 is remainder. 2 5s are 10. 5 plus 5 10. 10 plus 12. 12 is divisible by 3. So 3 8s are 24. 1 5. 3 5 is 15. 85 is not divisible by 2. 85 is not divisible by 3. 85 is divisible by 5. So 5 1s are 5. 3 5 5 7s 35. So the answer is 2 into 3 into 5 into 17. And for 92, 2 into 46, again 2 into 23, and 23 is a prime number, so 23 into 1. So we will write 2 into 2 into 23, and this thing I can write as 2 square into 23. So now this thing I can write same, 2 into 3 into 5 into 70. Now what we have to find? We have to find LCM. As explained earlier, LCM is the highest powers of all terms. Highest powers of all terms. Now just write all terms. All terms here are 2 into 3 into 5 into 17 into 23. 2 highest power em 2. With another power remaining all powers are 1. So the answer would be 4 into 3 into 4 into 4 into 3 into 5 into 7 into 23. So after solving, we will get the answer as 2 3 4 6 0. 2 3 4 6 0, and HCF would be least powers of common terms. So here common term is only 2 and least power of 2 is power 1. So HCF is 2. HCF is 2. Now what we have to do? We have to do verification. What is verification? We have to multiply those two numbers and we have to multiply LCM and HCF. Verification. Five 10 into 92 would be 46920. And we have to find LCM and HCF product. So 23460 into 2, it will be 46920, because 23 40 double just we will get 46920. So here also it is verified. Okay, now I'll take a gap of some 30 minutes or 20 minutes and I'll be live again, so that you will not be in a monotony. Okay, so let me end this live session here, and if you have any doubts, please feel free to ask via live chat session and comments. Thank you, and we'll be again live soon.